Thank you so much for choosing to spend a little bit of your afternoon with me. What I would like to do, if I can get this to move along, is talk about the value proposition of professional tools, because I've talked to several people today that have said, well, you know, how do you really differentiate yourself from GCC-based tools, which are basically free, and vendor-supplied tools? And it's a very fair question, and that's what I really wanted to focus my talk on. But one of the key things is the enhanced debugging functionality. We want to talk about tools that are pre-qualified for functional safety certifications. We also want to talk about live local technical support in the language that your team needs. And we'll also talk about code analysis tools. And I'm going to finish it up by telling you, why do you care? You know, what does this mean for me? And then we'll have a little bit of question and answer if you need it. So my key value proposition is, the short answer is that your time is not free. So professional tools, you know, are tested to a certain standard because proven in use doesn't really hold a lot, especially if you are trying to go for a functional safety certification. There's lots of people that can use free tools, but if you comb through some of the bug lists on the free tools, you'll realize proven in use doesn't mean that they're necessarily high quality tools. So when you're using tools that actually have a vested interest in correcting the tools and making sure that you're happy and satisfied with it, it can help you get to the market faster. One of the key things that we see some people doing with free tools is they try to hand optimize the code. And what they're trying to do is get maximum speed or performance out of the code. And so they're making all these tweaks to the assembly of the code or other things. And that's just simply not scalable, especially as code bases get larger. It becomes more intractable when you start dealing with multi-core devices, and it becomes a real problem when you start trying to debug multi-core code. Also, they are cross-platform, so if you want to migrate your tool or your project from ARM to RISC-V, or maybe MSP 430 or RL78 or a number of different architectures, we actually have tools that support all of those that make it easier for you to migrate into the RISC-V ecosystem. But one of the key things that really differentiates the professional tools is the ability to do enhanced debugging. So one key thing that you've probably seen demonstrated a little bit is the different types of tracing that is available on RISC-V architectures. So there's the N-trace, there's the E-trace, but having that live instruction trace can actually help you be able to debug things like protocol timing issues, when you have nested interrupts that are triggering, or you want to look at the performance analysis of your code. You can actually see the live instruction trace to see how long an algorithm is taking in order to be able to process your data. It also provides immediate feedback on your code behavior. So if you're in a functional safety setting, oftentimes they try to achieve 100% code coverage, except for those pieces of code that are there just in case you happen to get into one of those dark corners. Having live instruction trace helps you to prove that you have that. And if you don't have it, it helps to elucidate the different pieces of code that have yet to be executed so that you can help craft a test case. So it gives you a deeper understanding of your overall code flow. Also, there's conditional breakpoints that only trigger under specific conditions that you set. So it makes it much, much easier rather than setting a breakpoint and you start hitting the F5 key and your brain starts to wander, and then you think, I need to rearrange my sock drawer this weekend, and oops, I hit it one too many times. Now I have to reset and go back. So having those kinds of conditional breakpoints helps you to stop only when you're interested in it. So it helps you to focus debugging where it's actually needed. Therefore, it saves you time, carpal tunnel syndrome, saves keyboards, that sort of thing. But it helps you to isolate issues much more quickly. Therefore, you can focus your time on creating great projects that are based on RISC-V. Similar to that are the things that we call complex breakpoints. So you can execute macros before, during, or after the breakpoint. These are actually really good for doing things like automated testing. So if you want to load a test case onto a device, execute to a point, pull the test data off, and compare it to what it should be, it makes it very simple for you to be able to do that. You can evaluate multiple conditions to make sure that the breakpoint only triggers if all of those conditions are true. And it just makes your life very easy, especially when it comes to CI/CD processes, because you can actually put this onto an automated testing machine, and you can test on live hardware or you can test on simulators. It doesn't really matter to the tool chain, because it still gives you that same capability across them. So it effectively reduces the amount of time that you need in order to debug very complex issues. So functional safety certification. Now this is another hot topic, especially since RISC-V is really trying to get into the automotive market as well. We're starting to see some medical device customers that are looking at it in their R&D functionality, which is really cool to know that it's being considered outside of that. And we actually have a few aerospace customers that are looking into this as well. So what does a pre-qualified tool mean? What does this actually buy you? Well, first of all, you know that the tools have actually been rigorously tested. And when we say rigorously tested, it's not just, hey, there's a bunch of people using it. They've actually gone through a series of tests that are structured and actually go through a certification process, in our case through TÜV-SÜD, to verify the quality and the adherence to the different dialects of C and C++. You also get quality artifacts that show you the conditions under which the testing is valid, and also gives you tips and tricks on how you can safety certify your code at the end and stay within compliance of those safety certificates. So in our case, it's certified to several different types of what we like to call umbrella standards, that being ISO 26262 for road-going vehicles, IEC 61508, which is more of a genericized safety and embedded system standard, IEC 62304 for medical devices, and there's several others that I just won't bore you with. But basically what you get out of this is you get compliance with the safety standards, you know that it conforms to the language specifications, because I'm sure nobody in here has been bitten by cross-compiling, where one compiler interprets your C or C++ code differently than another compiler. Anybody ever had that besides everybody in the room? Okay, good. So you know what I'm talking about. So what we really want to do is we want to have it certified where you know it actually conforms to what the dialect says. And what this ultimately does is it reduces the liability that's associated with your code. Another cool thing that we bring to the market is comprehensive live technical support. We have offices in 12 different locations around the globe, and each one of them features technical support engineers that you can call or you can email, and they can jump on a Teams meeting and see what you're seeing and try to help you through this. All of these technical support engineers have worked as embedded developers, meaning just like you. They have done your job. They know what's going on, and they can help you with this. The mean experience time with IAR is 13 years, so it's not somebody that just started last week. They've actually been around the block a few times and know our tool chain inside and out. That also gives you the ability to do language localization. So if you have a team in China, you have a team in Japan, you have one in Korea, you have one in Germany, we have localized language support in those countries so that you can get real-time support for your team and in a language that is easier for them to communicate with the technical support. So you get immediate resolution of issues with qualified personnel. You get expert guidance and advice, and they're available almost 24/7. So from California time There's a small window between Saturday night and Sunday morning where there isn't an IAR office open. So if you run into a problem at that time, my advice is have a good dinner, get some sleep. There'll be one open on Sunday morning. So, all right, code analysis tools. How do we look at the code that we're writing? Because let's face it, everybody has a schedule that is put over them. And as we're writing code, we don't really have time to focus on what's the best coding practice on what we're writing. We try to put some stuff together. We try to write good code, but oftentimes we make mistakes because we're simply human, or we just pulled it off a SourceForge and hope it's not some 13-year-old kid who learned how to code last week that actually wrote that because it just seems to work. So what you really want to do is have code analysis, and I'm sure you've heard from several other folks that talk about how to statically analyze your code. There's also runtime or dynamic analysis. We actually have tools that provide both of those, and our static analysis tool is also functional safety certified. So it gives you early bug detection. So there was an interesting paper by Google several years ago that was published in the ACM that talked about when you give a developer feedback about their code is almost as important as the feedback you give them. And what it is it has to do with the survivor effect, because once somebody commits code, if it goes through and gets into the nightly build, now every defect that is found in that nightly build will count against their release metrics. So there tends to be this tendency for people to say, that's not a real bug. We should just ignore this. But if you give them feedback about the code that they just wrote while they're writing it or after they press enter, what happens is that they tend to treat that much more seriously. So in the Google paper, they said that once something goes into a nightly build, any issues that are found by the build system have a 21% likelihood of being treated as serious defects. But if you give them near instantaneous feedback, in other words, within a few minutes at most of when they write the code, they have a 74% chance of taking that feedback seriously as, yeah, I need to look at this and I need to fix this. So there is the survivor effect, and having that kind of feedback that is easy and integrated into the tool chain is actually something that's going to give you better quality code, which means that you're going to get it out to the market much, much faster. So if it's integrated into the workflow and you make it easy for engineers to use it, they are much more likely to use the tool chain. And if you make it simple and painless, and it means that they don't have to have feedback sent to their manager that, hey, I put yet another bug into the code, it means they're much more likely to accept the feedback, and it becomes a teacher to them how to write better code as they go along. So it's a really cool integration of the things that we have. So now you're probably thinking, well, all this sounds great, but why do I really care? Well, the answer is time is money. We know this expression. The less time you spend writing and debugging your code, the less time your company spends making a product, which means that it costs them less money. So the faster your product is released, the sooner your company can recoup the costs, and professional tools will allow your product to get out the door much more quickly. And the cost of professional tools is far outstripped by the time savings for the company, because if you think about how many people are on your engineering team and how much money you're paying them, particularly these days, it does not take very long for you to outstrip a few $1,000s for a tool chain for each individual developer. One defect, one problem, 1 hour of savings per month will more than pay for the cost of professional tools. It's very, very simple. Higher cost projects are less likely to have follow-ons, so if you have cost overruns because you couldn't get the code or the product out the door, you're less likely to actually have another project that uses that as a basis. And projects that overrun that initial budget and time estimates have a much higher likelihood of getting canceled, which is something that nobody wants to have happen. So in summary, what we like to say is that professional developers should be using professional tools. And that enhanced debugging will help save a lot of time for you. And if you're in the functional safety space, using a pre-qualified tool chain helps you get to your end functional safety certification much more quickly. And when you run into problems, having a professional guide that you can call and say, hey, I'm having this problem, can you please help me with this? Oftentimes, we can find and diagnose problems in about 5 to 10 minutes. So having that quick feedback where you can get on your way and go back to developing your awesome application is well worth the time that it takes to call in. So code analysis also provides a cheap automated way to find and fix defects in your code, and you care because time is money. So that is what I have to say, and I'm sure